Stop and think. A single gram of antimatter contains enough energy to match the explosion of the Nagasaki bomb. But what if instead of imagining it as a power of destruction, we saw it as the greatest opportunity for clean and concentrated energy in all of history? Today, you will discover why antimatter could be the key to humanity's future and why that potential is still beyond our reach. First, let's be clear about what we're talking about. Antimatter is the mirror form of ordinary matter, made up of antiparticles that when meeting their corresponding particles annihilate each other and release energy. In short, for every particle there is an antiparticle, electron and positron, proton and antiproton, and so on. And this is not just theory. We already produce and use antimatter in laboratories and hospitals, for example. With that said, picture a paper clip on your desk. It weighs only 1 gram, almost nothing. Now imagine that same gram releasing enough energy to power a large city for days. The difference between weapons and power plants, after all, is not in the fuel, but in how we choose to use it. Einstein's equation, E equals mc squared, shows that mass can be transformed into energy. While nuclear fission releases only 0.1% of that potential, and fusion reaches 0.3%, antimatter converts 100% of mass into pure energy. It is, in theory, the most efficient energy source in the universe. And here we reach a paradox. As explained earlier, we already handle antimatter every day in small quantities. In hospitals, PET scans release positrons that collide with electrons in the human body, creating flashes of energy that map neurons. If we can do this on a microscopic scale, why can't we expand it to power entire cities? The answer lies in production. CERN in Switzerland can manufacture about 10 million antiprotons per minute. That sounds impressive, but even at this rate, it would take 100 billion years to produce just 1 gram. In other words, producing enough antimatter to be used as fuel is far beyond humanity's current capabilities. And even if we had that precious gram, the cost would be unthinkable. $62 trillion. That's more than the entire world's GDP in a year. But physics doesn't care about our financial limitations. It continues to show that if we ever master large-scale production, the energy return would simply be unbeatable. Another challenge lies in storage. Antimatter cannot touch anything, not even the air we breathe. That's why it needs to be suspended in magnetic fields inside vacuum chambers colder than interstellar space. So far, the world record has been storing a few hundred antihydrogen atoms for a few minutes. It's not exactly a fuel tank, but it's the beginning of a technology that could one day mature. And why do scientists persist in this effort? Because the promise is enormous. Imagine spacecraft propelled by just a few milligrams of antimatter, able to reach Mars in weeks instead of months. Imagine hospitals using antimatter beams to destroy tumors with absolute precision, sparing healthy tissue. Or power plants that operate without pollution, without radioactive waste, without the carbon burden that now suffocates our atmosphere. But perhaps the most profound application lies not in engineering or medicine, but in cosmology. Each atom of antimatter studied helps answer the biggest question of all. If the Big Bang created matter and antimatter in equal amounts, why is the universe we see made only of matter? Where did the other half go? Discovering this answer would not only give us a new source of energy, it would reveal the very reason for our existence. Antimatter is, therefore, a fascinating paradox. It is the most expensive and rare substance we know, and at the same time, the most promising as a source of clean and limitless energy. It's as if the universe showed us the formula for an inexhaustible source of power, but locked the key away in an almost impossible vault. Another intriguing fact about the cosmos, already covered here on this channel, concerns dark matter. If you want to know more about that subject, click on the card above and prepare to be amazed. Returning to antimatter, we know that humanity's future may depend on learning how to turn that key. We may never see antimatter bombs, but it's possible that we will see spacecraft powered by it crossing the stellar oceans. The question is not whether it's possible, but when we'll be able to turn physics into engineering. And here's the reflection. Will we ever learn to produce and store antimatter on a scale large enough to power our civilization? Or will this always remain a power beyond our reach, reserved only for the stars? If you want to keep exploring the greatest secrets of the cosmos and the energies hidden in the very fabric of reality, subscribe to the channel and ring the bell. The universe still holds explosive answers, and we are going to uncover them together.